Hi everyone, this video is on the mixed exercise 9 question 39. So we want to find the derivative of arc sine x over square root of 1 plus x squared. So in order to solve this question, we first need to remember a general result because we can use the general results for questions that we have um, when we have inverse trigonometric functions. We can use some general results to save a bit of time. Of course, you can go and just derive and differentiate this directly, which I have done in some videos and you can watch in the section of trigonometric differentiation. But I think it's slightly quicker if you use the general results. So the result that we just need to remember for arc sine of any function is basically this. So let's say you have a function f of x and you want to find the derivative of arc sine f of x. So you have the arc sine of a function and you want to find its derivative with respect to x, then it's going to be equal to f dash x over the square root of 1 minus f of x squared. So this is basically the method that you can always use to find the derivative of arc sine of any function. And here it's just the wrong bracket, so the bracket is actually here, 1 minus f of x squared. Okay, so yeah, what this means is that in this question, f of x is obviously the function that is inside the arc sine, and that's equal to x over the square root of 1 plus x squared. So that's f of x for us. Now, in order to find the derivative of arc sine of this function, we first need to find f dash x, and then we just need to substitute them into this formula, and that's it. So if we want to find f dash x, we can first rewrite this as x times 1 plus x squared to the power of minus a half, right? Because this way we can use the chain rule to differentiate this, and of course we could use the quotient rule as well, but I think the chain rule is probably quicker at this time. And chain rule and the product rule, obviously. So in order to find the first derivative, I'm going to write down the first function times the derivative of the second function. So this is the first function, this is the second function. The derivative of this bracket is going to be, first of all, the power comes down because it's the chain rule, and then the derivative of inside is 2x, and the whole thing, this coefficient times the function itself, but with power minus 1. So minus a half minus 1 is minus 3 over 2. That's the first part of the product rule. The second part says differentiate the first function and then times the second function. So x differentiates to 1, and it's just going to be 1 plus x squared to the power of minus a half. Okay, so this is the derivative, and of course we can go and simplify this further. And now, let's simplify this first before the substitution part. So here we have this half cancels out with this 2, and we have x times minus x, which is minus x squared. So minus x squared and times 1 plus x squared to the power of 3 over 2 minus 3 over 2. And then we have this plus 1 plus x squared to the power of minus a half. Okay, at this point we can go and write this in terms of fractions, but I think it's okay for now, so we don't need to do so. Now we have f dash x, so getting back to the general result that we have, we can now substitute that into this formula. So f dash x goes to the numerator, and then the denominator is just the square root of 1 minus f of x squared. So we can now write that dy by dx is equal to, so again, the numerator is f dash x, so f dash x is just minus x squared times 1 plus x squared to the power of minus 3 over 2 plus 1 plus x squared to the power of minus a half. And now the denominator is the square root of 1 minus f of x squared. So f of x is just x over square root of 1 plus x squared. And if we square that, it's just going to be x squared over 1 plus x squared. So 1 minus x squared over 1 plus x squared. Okay, so as you can see, it's not in a very nice form, but that's fine because the question is not about simplifying this and giving in the nicest form. Okay, that's it for this video, and thank you for watching.